It is the convention that current indicated by a plus sign is positive when it is flowing inwards in the conductors R, Y, and B, and outwards in R1, Y1, and B1. The currents indicated by dots are considered negative and flowing outwards. The current in the three phases are represented by the curves in figure. You can observe that the current in phase R is at maximum positive value at instant A. At the same instant, the currents are negative in phases Y and B, and their magnitudes are half of maximum value. These currents produce magnetic fluxes. They are represented by the dotted lines as shown. The resultant flux axis is indicated by the flashing arrow NS. After some milliseconds, the R phase current reaches the instant B. Now, both the currents in phases R and B will be 0.866 times the maximum value. The distribution of magnetic flux due to these currents is shown. The axis of magnetic field is now in line with coil Y and Y1. It could be observed that the line of magnetic field has turned clockwise by 30 degrees from that of the instant with maximum current in the first figure. At instant C, the current in phase B attains its maximum negative value. The current in R and Y are now both positive, but their magnitudes are being half the maximum value. The magnetic fluxes produced by these currents are shown. The axis of this flux could be seen displaced clockwise by another 30 degrees compared with the previous instant discussed. So, for every interval of time corresponding to any angle along the horizontal axis, the axis of the magnetic flux moves forward by the same angle in space. This means that the flux rotates through one revolution in one cycle. This is the synchronous speed of a two-pole motor. Therefore, it is seen that the magnetic flux is rotating at a synchronous speed inherently in a three-phase induction motor,